Here we are at example 5c from our 1.4 set of notes. We're asked, without graphing, determine if this function is in fact continuous or not. And we see that this function is f of x is equal to the absolute value of x, and we're looking specifically where x is -3. So for our first criteria, let's just go ahead and see if we can go ahead and plug in that value and if it in fact exists. So f of -3 simply just comes out to be the absolute value of -3. And the absolute value of -3 just comes out to be +3. So, yes, I would say then when we plug that value in, it does in fact give us a real value. So criteria 1 is in fact met. Looking now at criteria 2, the limit as x approaches -3 of our function, well, that's the same thing as saying the limit as x approaches -3 of the absolute value of x. And again, we can go ahead and use direct evaluation. And when we do that, we end up with 3. So yes, this does in fact exist. Likewise, this guy existed. So it looks like criteria 2 does check out. Now looking at criteria 3, do they in fact match? Yes, they do. The limit as x approaches -3 of the absolute value of x is in fact equal to f of -3, because again they both ended up coming out to be +3. So as a result, is this function continuous at x equaling -3? And the answer is yes, this is continuous. At x equaling -3. So again, though, that is example 5c from our 1.4 set of notes.